Hi, this is question 5, and we've got a nice normal distribution question here. So it says, the records for a school athletics club show that the height, h meters, achieved by students in the high jump is normally distributed with a mean of 1.4 meters and a standard deviation of 0.15 meters. Find the proportion of these students achieving a height of more than 1.6 meters. Okay, so that's quite nice. That's just going to be the normal distribution, and we're just going to put 1.6 as our lower value and our upper value just a really big number. We're going to put in a mean mu of 1.4 and a standard deviation of 0.15. And when we do that, that gives us a value of 0.0912. So that's our answer for A. Now, it says the records also show that the time t seconds to run 500 meters is normally distributed with a mean of 330 seconds and a standard deviation of 26 seconds. The school's head would like to use these distributions to estimate the proportion of students from the school athletics club who can jump higher than 1.6 meters and run 1,500 meters in less than 5 minutes. Okay. State the necessary assumption about h and t for the head to calculate an estimate of this proportion. So the assumption is that the events h and t are independent of each other. Okay, so we're going to assume that they're not, that one is not dependent on the other, they're independent. So that's our assumption. Whether it's true or not, I don't know, but we're going to assume that you need to assume that they are independent. Now, part C. It says find the head's estimate of this proportion. So we need to work out, we've already worked out the probability that somebody can jump greater than 1.6 meters. So now let's find the probability that they can complete the 1,500 meters in less than 5 minutes. So 5 minutes is equal to 5 times 60, so that's 300 seconds. Notice that this distribution is measured in seconds, so we need to convert those 5 minutes into seconds. So we're looking for a probability of t is less than 300, okay, where we have a mean of 330, we're told, and a standard deviation of 26. So again, we're just going to put that into our calculators for the normal distribution, and we're going to get 0.12428. Now, because we've got the word and they've put the word and in bold, remember when you hear the word and in probability, it means you need to multiply the two results. So the students who can do the 1.6 meters and run in the 1,500 in less than 300 seconds are the two probabilities multiplied together. Okay, so that's our answer to part C. Now, what's next? Part D. Students in the school's athletics club also throw the discus. The random variable discus is normally distributed with mu and sigma squared, represents the distance in meters that a student can throw the discus. We're given two pieces of information there, and we're asked to calculate the value of mu and the value of sigma. Okay, now the way that we're going to do that is we basically need to generate a pair of simultaneous equations, okay? And we need to use this coding z is equal to x minus mu over sigma, where z is our standardized normal distribution. So what we need to do is we get our calculator. I've got the old trusty 991EX here. We go to our distributions, okay? Whoops, there we go. And we're going to go to inverse normal, okay? Now in this question, we've got to find, what are we trying to find? Yeah, so we've got here you'll notice here we have a probability of 0.3. So we're going to put in an area of 0.3, and you'll notice that the calculator already defaults to the standardized normal distribution, which has a standard deviation of 1 and a mean of 0. So when I put that into my calculator, I find I get this value, okay? Now, the question is, do I want the plus or the negative one of these values? And the answer to that is I want the negative in this particular case because I'm over at the left-hand side of the distribution. Because remember, our standardized normal distribution is symmetrical about a mean of 0. So if we are talking about the less than, which we are in this case, we're over at this side of the distribution. So that for that reason, we want the minus 0.52. So our z value is the minus version of this. So I've written that there. And that is equal to x, which is 16.3 minus mu over sigma. So all I've done then is multiplied that by sigma, and I've added mu to both sides, and that's generated one simultaneous equation. We now do the same at the other end of the distribution over here, where we've got greater than 29, and we have an area over here of 0.1. So we're going to go back to our standardized normal distribution, take the inverse, put an area in of 0.1, and we've got there, the calculator comes up with minus 1.28. Now we want the positive value of this because we're over at the right hand side of the distribution this time, because we're dealing with the greater than symbol. Okay, so therefore we've got 1.2816 is equal to 29.0 minus mu over sigma. So we now times both sides by sigma and add mu, and that gives me my second simultaneous equation. Now, we can't just put those in the calculator and generate the answers without losing marks, because there are method marks in the mark scheme for actually solving them. So we take our two equations, and I've said label them equation 2 and equation 1, and I've said we're going to do equation 2, take away equation 1. So we do that, we get they cancel, 2 minuses become a plus. We get 1.8066 equals 12.6, so our standard deviation is 7.03. Once we know the standard deviation is 7.03, we then go to either of the equations, sub that result in order to calculate our mu, and that gives us mu is equal to, I've put 19.99. So that is how we find our mu and our sigma. I thought that as normal distribution questions go, that was quite a nice one. Really, nothing too radical there. So I hope you found that helpful, and I will see you in the next video.